Okay, hello class. Chapter 7, we're going to talk about momentum. Good news is momentum is something we all already know about, right? If you have a car is a massive object, it's moving, we would say it has momentum, right? We know that if the car was to, crash into a tree or something, right? Wear your seatbelts. Right, but say it was, or just moving. We know it has a lot of momentum. Well, of course, this is physics class, so we're going to quantify that and use math to make predictions, right? The universe, math is an amazing thing. This is humans develop math, and it turns out the universe works that way, right? It's mathematical. So momentum is mass, right? The mass of the car times velocity. Well, that kind of makes sense. You're like, oh yeah, that's kind of what you already thought. The massive car is moving, so it has velocity. Turns out that's exactly what it is, mass times velocity, right? And then there's a related term called impulse, right? We all sort of know what impulse is as well. It'd be a force, right? Force is in newtons, we know that. And impulse is something like we've been talking about force. If you're pushing a box, you can continue to push on it. Well, what if there was a box and you just kind of went up to it and just pushed it real quick, right? That's impulse. You just pushed it real quick, and maybe you just sent it sliding. If it was on ice or something, you would push it, and now so that's impulse. It's related, right? So momentum and impulse, two phenomenon you're already familiar with, but we're going to quantify it and use math to really understand it, right? So let's do that. And then this video, I'm just going to kind of go over these core concepts, and then the next one we're going to get into it in more depth, impulse and momentum, because there's a lot more to it. But I just want to quickly cover these core concepts. Okay. So momentum is represented by the symbol P, because you can't use M because it's already taken by mass and other such things. So P is equal to mass. So you can't use mass, it's already taken, times velocity. Well, what are the units? Well, mass would be kilograms, and then velocity is meters per second. Okay, that seems reasonable, right? Then we talked about impulse. Okay, impulse. And I said that was force times time, right? You push something, but you can push on it quickly or just kind of nudge it a bit, right? So that would be impulse is equal to force, and then we'll say times time, but a change in time, right? So I'm just going to put delta t. I'm going to use a script t, just to show. Well, it could be like maybe it could be half a second or a second or even like 2 seconds, right? So there's some time went by, and what are the units for that? Well, force would be newtons. Time would be in seconds. And so then, so that would work out to, right, a Newton seconds, that is a, kilogram meters per second squared, okay, because force is equal to mass times acceleration, so kilogram meters per second squared, and then times time, so times seconds, hey, my marker is going. So now you have a second square down here, that cancels with this second here, and you end up with units of kilogram meters per second. Can you see that? Kilogram meters per second. And so that's for impulse. And notice it's the same units as for momentum. So interesting. Now they're different phenomena. We talk about them in different ways, but they're closely related. They impact each other, right? Right? An impulse can change momentum. We'll just go like that, right? So the units, kilogram, meters per second, okay? And we'll go on to the next video. Make sure you can see that.